All right, so let's distribute the 2. What's 2 times x? 2x. And then a positive 2 times a negative 4 is? Negative 8, good, equals 5x plus 2. Now we do have like terms, right? We have the 3x and 2x, and we have this 5x. Okay. Now, if they're on the same side, we just combine. What is 3x plus 2x? 5x. So we have 5x minus 8 equals 5x plus 2. Now, how would I move the 5x to the other side? Subtract it. What's 5x minus 5x? 0. So I'm left with negative 8 equals 5x minus 5x is 0 again. I'm left with 2. So we have no variable left over, right? So does negative 8 equal 2? No. So what's my answer? There's no solution. Good. If those numbers equaled each other, what would it be? Infinitely many. Good. Or all real numbers. All right. In number 2, what am I distributing first? A 6, right? And then on the second one, what would I distribute? A negative 2, right? We cannot do 7 minus 2 first. We have to distribute first, right? Multiplication always comes first. So 6 times x, 6x, 6 times 3, minus 2x. Keep the 7. Negative 2 times 4x is negative 8x. And negative 2 times 5 is negative 10. All right, so let's go ahead and combine like terms on the same side. 6x and negative 2x is what? 6x minus 2x is 4x. So we have 4x plus 18. Over here, don't we have a 7 and a negative 10? And what's 7 minus 10? Negative 3 minus 8x. Now let's combine the x's, okay? They're on different sides. So do you guys want to move the 4x or the negative 8x? I'd probably do the 8x. And how would I move a negative 8x over? Add it. Good. So what's 4x plus 8x? 12x. So we have 12x plus 18 equals negative 3, because these would cancel. And now what? Subtract 18. Yep. So we have 12x equals a negative 21. And then what? Divide by 12. And can I divide negative 21 by 12? No, but I can simplify it. What does negative 21 over 12 simplify to? Negative 7/4. And there you go. Now I made these problems up, so that's why that one probably ended up as a fraction. Okay, and computer away now, please. Thank you, sir. All right, so today we're going to talk about proportions. Okay, and does anyone know what a proportion is? I know you've solved these before, Jake. You don't know? Have you seen them though before? Or you've heard of the word before? Okay, let's start with a ratio. What's a ratio? Anyone? Go ahead, Michael. Huh? It is. It's a comparison. So a ratio is a comparison. I can't even spell. Comparison of 2 or more things. Okay. So we can do a ratio to boys to girls to this class, right? Boys to girls, how many freshmen there are to seniors. Okay. It compares 2 or more things. There's different ways you can write ratios. What's one way? Yeah. What's one way? Go ahead, Peter. A fraction. Yeah, so we can compare like boys to girls, so 2 to 3. Oops, you can't even see that. That's one way we can compare, right? What's another way? Yeah, colon. So 2:3 or 2 to 3 with the word 2. And again, you can compare more things than just 2. So we can have 2:3:4 if we wanted to, or back to 2, okay, depending on what we are comparing. A proportion, okay, a proportion is an equation. So what's an equation? What's an equation? What's the big thing that has to have an equation? Huh? An equal sign, yeah. So a proportion is an equal sign, an equation that states that 2 ratios are equal. So we could have A to B equals C to D, or I like it better looking at it as a fraction. A over B equals C over D, okay? A and D are known as the extremes, and your means are your B and C. Okay? Does anyone know how to solve proportions? Yeah, we cross multiply. So we're going to cross multiply and set them equal to each other. So we multiply the extremes, we multiply the means, and we set them equal. So if A over B equals C over D, then A times D will equal C times B, or B times C, however you want to write it. And then could we solve for missing letters if we really wanted to? Yeah. Okay. Now, one thing, if we throw in plus or minus signs, so say we had something like A over B equals C plus E over D. When we go to cross multiply, we do the same thing. We do A times D, set it equal to B. Now we have to make sure we put the quantity of C plus E inside the parentheses. So make sure if you see a plus or minus sign, you always have to put them around in parentheses, okay? All right, so let's go ahead and solve. 3 over x equals 5 over 4. So there's no plus or minus sign, so can I go ahead and just cross multiply? Yes. So 3 times 4 is 12 equals 5 times x is 5x. Now, would it be okay if I put it as 5x equals 12? Yeah, it doesn't really matter if you put the extremes equal the means or the means equals the extremes. And now, how do I solve for x? Divide by 5. So my x is actually equal to what? 12 over 5. And we always leave it as a fraction. Thank you. All right. Let's go ahead and do B. We have 3 over n equals 8. That's kind of not really a proportion, is it? But really, 8 is the same thing as 8 over what? 1. Now, can we cross multiply? Yeah. So 3 times 1 is 3. 8 times n is 8n. And then set them equal to each other. And now, how do I solve for n? Divide by 8. So n is equal to 3 over 8. There you go. Now, looking at C, what's different with C? There's a negative. So let me ask you, does that negative go to both numbers or just one of the numbers? Just one. Now, does it matter which one you put it with? No. So I tend to always put it with the number, not the variable, whatever the number is. But it doesn't matter. Just make sure you put the negative with one of the numbers, not both. Okay. And now let's cross multiply. What's 4 times 15a? 60a, yeah, equals 21 times a negative 2, negative 20, or negative 42, sorry, negative 42. And then how do I solve for a? Divide by 60. So a would equal, now negative 42 over 60, I can simplify that, right? What can go into both of those? A 6. And 42 divided by 6 is 7. So negative 7 over 10. There you go. All right, go ahead and do D. And do D. I think this section is a good break from last chapter. You guys agree? Yeah. The good news is we're done with the hardest chapter. So it gets easier from here on out a little bit, okay? So the one thing with this class is we do all the hard stuff first, and then it gets easier. So where'd you guys put your negative? In the numerator or denominator? Denominator this time? All right. All right. So let's go ahead and multiply. What's 3 times 6? 3x times 6? 18x. And then what is 12 times negative 3? Negative 36. And then how do I solve for x? Divide by 18. And what do we get? Negative 2. Hey, we actually get a whole number now. All right, looking at example 2 here. Okay. What's different? We have those pluses and minus signs. So as soon as I see that, I tend to always put them in parentheses. So anytime I see plus minus, I put them in parentheses there. So then we still are going to have a fraction equal a fraction. So we're still going to cross multiply, right? Okay. So now we're going to take 15, and I'm not going to circle because then it gets really messy. I'm going to take 15 and multiply it by the quantity of what? X minus 4. And then I'm going to set it equal to 3 times 2, which is just 6. Now, do we know how to solve this problem once it's set up as an equation? Yeah. What's my first step? Distribute. What's 15 times x? 15x. 15 times the negative 4 equals 6. And then what? Add 60. So we get 15x equals 66. And then what? Divide by 15. Now, can I divide 66 by 15? No, but can I simplify it? Yeah, what can go into 66 and 15? 3. And I get what? 22 over 5. Almost put 33. Whew. All right. All right, see, does it matter which multiplication I do first, which diagonal? No. So I'm going to go ahead and just go down. So I'm going to take 6 times this quantity of 2n minus 3 equals what? That means 5 times n plus 2. And now we're going to distribute, correct? Yeah. 6 times 2n, 12n. 6 times negative 3. Great, put your computer away, please. 6 times negative 3, negative 18. 5 times n is 5n. And 5 times 2 is 10. All right, do you guys want to move the 5n or the 12n? 5n, how would I move a 5n? Subtract it. So what's 12n minus 5n? 7n minus 18 equals 10. Then what? Add the 18. So we get 7n equals 28. And then what? Divide by 7. So at n equals 4. Good. Go ahead and do B and D on your own here. Go ahead and do B and D on your own. did you guys look at B? You see that 3x minus 4, so I'm always going to put it into parentheses, right, as a quantity. So let's go ahead and multiply. Do you guys want to do the 2 times x first or 5 times the quantity of 2x minus 4? Okay, does it matter? No. So I heard, let's do the 2 times x first. So we have 2x equals 5 times the quantity of 3x minus 4. So now we're going to distribute first. So 5 times 3x is 15x. And 5 times a negative 4? Negative 20. So now, am I going to move that 2x or the 15x? The 15. And how would I move the 15? Track it. And the reason why we're moving the 15 is because x is by itself on the left side. If I move the 2x, you're going to add another step to it, right? You'll have a 0 on that side. So that will cancel. 2x minus 15x is negative 13x equals, we have a minus 20, so negative 20. And then divide by what? Negative 13. So x would equal, what's a negative over a negative? A positive. And can I simplify 20 over 13? Nope, so we leave it as 20 over 13. All right, now looking at D here, what's different with D? This 2x minus 2, if I put it in parentheses, what is that all over? 1. And now, once I set it up as a ratio equal ratio into a proportion, can I go ahead and cross multiply? Yeah. So I'm going to take 1 times 5 times the quantity of x minus 3 is going to be equal to what? 11 times what? 2x minus 2. And now let's go ahead and distribute. What's 5 times x? 5x. And 5 times negative 3 equals 11 times 2x and 11 times negative 2. Okay. All right, now, do you want to move the 22x or the 5x? The 5x, and how would I move a 5x over? Now, would it matter which one you move? No. So we have negative 15 equals 22 minus 5 is that 17x minus 22. Okay. Now, solving for the x, how do I move the 22 over? Add it. And what's negative 15 plus 22? 7 equals 17x. And then how do I get rid of the 17? And so what does x equal? 7/17. Perfect. Good. Any questions with this so far? Yes. No. No. You can always move the constants before the variables. I have a habit of always doing variables first, but no, it does not matter. Okay. Huh. You do constants too? Yeah. So it doesn't matter. So someone asked, is it okay if you move constants first? Yes. I always tend to do variables, but constants, you can go first. It doesn't matter the order you do them. Okay. All right. Now, your guys' favorite story problems. Yay. All right. These aren't too bad. Okay. So it says, with a 5-pound bag of flour, the cooking class can make 120 date nut muffins. Can we write a ratio from this? Yeah. What is that ratio?
5.
Right. 5 pounds over 120 muffins. Yeah. Perfect. Thank you. Okay. How many muffins can you make with a 2-pound bag of flour? So can I make another ratio? Now, because my first ratio is pounds over muffins, my second ratio has to be what? Pounds over muffins. Well, what? We want to know how many muffins we can make 2-pound bags. So where's that 2 going to go? In the numerator. And then what's going to go in my denominator? X. Yeah. Can we go ahead and cross multiply and solve? Yeah. So 5 times x is 5x. 120 times 2 is 240. And then what? Divide by 5. So X would equal 48. Is that right? So what does that 48 represent? Muffins. So with a 2-pound bag, we can actually make 48 muffins. Would you be able to figure out if I had a 7-pound bag? Yeah, okay. So if you're looking at this kind of stuff, setting up proportions, the easiest thing, right? Look at your ratios. Now, is this the only way to write this? No, I could have done 5 pounds over 2 pounds would equal 120 over X. Okay, it doesn't matter. Yeah.
I just did 120 times 4.
Wait, 120 times what?
0.4.
0.4, because you divided it. Yeah, because, okay, yeah, that works too. Yeah. All right, example 4. About 8 gallons of gas filled the tank after Greg drove 224 miles. How many miles can he expect to drive in a full tank of about 13 gallons? Can you guys set up a proportion there? You can go ahead and put your computer away as well, too, please. Thank you, sir. So what's one way I could write a proportion? Go ahead. Huh? Okay, so he did 8 gallons over 224 miles. Did you make that thousands? Okay, I was like, huh? Equals, now what would my other ratio be? Because I did gallons over miles, the second one has to be gallons over miles. So what's the next thing given? 13 gallons, and we want to know how many miles, so X miles. We go ahead and cross multiply. 8 times X is 8X. Michael, what's 224 times 13? Okay. And then how do I solve for X? Divide by 8. So X is, do you know it? 364 what? Miles. There you go. So on 13 gallons, he can drive roughly 364 miles, give or take some, right? If you want to run out of gas. Okay, keep going. All right, any questions with 7.2? Pretty straightforward. Okay. Now, 7.3, we're not going to do it all. We're just going to do a few of them, okay? We will not do the story problems today, okay? So we'll look at here. And if you notice, okay, here's some review problems. We'll go ahead and skip that for a second. We'll come back to that, okay? Let's look at A here, okay? Let's look at example 1A. X over 7 plus X over 3 equals 10. Right? Now, we learned how to find common denominators, right? But I'm going to show you a way that you don't have to do all of that we did last class. Okay? Do you guys like fractions, honestly? No, you try to avoid them at all costs. Is that correct? Okay. So what I tend to do is I like to get rid of them. Okay. So I like to, first off, 10 is the same thing as 10 over what? 1. Okay. So what I tend to do is I find the common denominator. Do we know how to find a common denominator? Yeah. And then once we know the common denominator, I can multiply every term by the common denominator. And if I multiply every term by the common denominator, guess what? You will not have a fraction anymore. Right? Let's look at that. All right. So let's think about 7, 3, and 1. What can 7, 3, and 1 all go into? Huh? 21? Okay. I thought you said 51. I'm like, huh? All right, 21. So my common denominator is 21. So I'm going to multiply everything by 21. Okay. Now I'm going to show this long way just so that you guys can see why this works. So I'm going to take X over 7 times 21 over 1. What happens to the 21 and 7 if we're multiplying? Can't I cross simplify it? Yes. So what is 21 divided by 7? 3, right? So what is just 3 times X? 3X. Now, if I take x over 3 times 21 over 1, what happens to that 21 and 3? It cancels down to what? 7, right? And what's x times 7? 7x. And then we're just taking 10 times 21, which is 210. You guys see how if we multiply by the common denominator, we can cross simplify everything? Meaning, do we have a fraction left over in every single one of these? No. So now, once there's no fraction, doesn't that make that look a lot easier? Yeah, what would I do? Combine like terms, right? What's 3x plus 7x, 10x, equals 210. And then what? Divide by 10, so x is just 21. Now, it won't always work out that it's the common denominator, but okay. That's what I like to do with these types of problems because I don't like to deal with fractions as much as you guys don't like to deal with fractions, right? And this will work on every single one you do. You just have to make sure you multiply every single term. Okay, so let's look at B. What's the common denominator between 5, 2, and 10, or 20? 20, right? So I'm going to multiply everything by 20. I don't care how you write that. Okay, I just did it this way. Okay. If I'm taking 3a over 5 times 20, what's 20 divided by 5? 4, right? So that would break down to 4. So it's 3a times 4. Isn't that just 12a? All right, what's 20 divided by 2? 10, right? So it's a times 10. 10a. And then what is 20 divided by 20? 1. And what's 1 times 1? Now, do we have any fractions? No. So let's go ahead and solve. What's 12a minus 10a? 2a equals 1. And then how do I get rid of that 2? Divide by 2. So a equals what? 1 over 2. What do you guys think of that? Not too bad? All right. Looking at here. 5, 3, 5, and 1. What's my common denominator? 3, 5, and 1. 15. So I'm going to multiply everything by 15. You guys okay with that? Let's do the 2 times 15 first because that's easier, right? What's 2 times 15? 30. So that's going to equal 30. Okay. Now, x over 3 times 15. So x over 3 times 15. 15 divided by 3 is what? 5. And 5 times x is 5x. Is everyone okay with that? All right, minus. We have this x plus 2 over 5 times 15. And I always divide first. What's 15 divided by 5? 3. Now I'm going to take 3 times what? X plus 2. So what do I need to put with the x plus 2? Don't I need to put parentheses around that? Right. Now, aren't we back to solving equations like we did before? Yeah. What's my first step? Distribute. And what am I distributing? -3. So it's -3 times x. -3x. And what's -3 times 2? What is 5x minus 3x? 2x. And keep solving. So how do I move this 6 over? Add 6. So 2x equals 36. And then what? Divide by 2. So x equals 18. Any questions so far? Then B here. 2n is the same thing as 2n over 1, and 5 is over 1. So what's my common denominator between 1, 3, 4, and 1? 12, right? So I'm going to go ahead and multiply everything by 12. Can we do that? Yeah, let's do the ones that have over 1 first. What's 2n times 12? 24n plus. What's 5 times 12? 60. All right. So now let's do our middle terms. So we have n over 3 times 12 over 1. What's 12 divided by 3? 4. So what's 4 times n? 4n. Okay. What's 12 divided by 4? 3. And what's 3 times n? Oh, we have no fraction, do we? Can we go ahead and solve this? So it's 24n plus 4n. 28n. And then how do I move the 3n over? So we have 25n equals 60. And then what? Divide by 25. Now, can I divide 60 by 25? No, but I can't simplify it. What can go into 60 and 25? Can't the 5? So what's 60 divided by 5? 16 divided by 5 is 12. Over 25 divided by 5 is? There you go. Thank you. What do you guys think about that, getting rid of all those fractions? Does that make it easier, you think? Yeah, I think so. All right, now, the last ones we want to do, these two, and then we'll be done for the day. Okay, if you notice, there's a lot of fractions in this. Do you guys see that? So there's two ways we can actually do this. We can distribute the fractions first, or we can get rid of the fractions by multiplying by the common denominator. However, when we do it like we were up here, these are in parentheses, so we'd leave them alone. Because remember, 1/4 times that, isn't that the same thing as n plus 2 over 4? Is that the same? Yes. Minus n minus 2 over 6, aren't those the same? So that's why when we multiply by the common denominator, we actually don't multiply yet to that n plus 2 or the n minus 2, okay? Equals 3 over 2. So we only multiply, kind of simplify the denominators. Excuse me. So what is my common denominator between 4, 6, and 2? 12. Yeah, so let's multiply everything by 12. Can we do that? I think so. Let's do this one first. 3 halves times 12. What's 12 divided by 2? 6. So 3 times 6 is 18, right? You guys okay with that? All right. What's 12 divided by 6 here? 2. So we're going to take 2 times n minus 2. Are you guys okay with that? Okay. That's minus sign. 12 divided by 4 is 3. So I'm going to take 3 times the n plus 2. Is everyone okay with that? Yeah. All right. Now, what's my first step? Distribute. 3 times n, 3 times 2. What am I distributing in the second one? A negative 2. So negative 2 times n, negative 2n. What's a negative 2 times a negative 2? Is that a positive 4? Now combine like terms. 3n minus 2n is just n. 6 plus 4, 10 equals 18. So what is n going to equal in this one? N is going to equal 8. Why? So you have to subtract the 10 to the other side. Okay. All right. So now here, okay, we have this 3/4 times the x minus 2. This one's a little bit different because now my numerator is not 1, is it? Okay, so we're going to kind of do the same idea here, but what are we going to multiply by? What is my common denominator between 4, 3, and 2? 4, 3, and 2. 12, right? Right? Can 12 go into all of those? So I'm going to multiply all of these fractions by 12. Can we do that? Yes. Okay. So we're just doing the fractions, not the x minus 2, because that's going to be our numerator, right? So let's think about this. 12 divided by 4 is what? 3. And what's 3 times 3? Oh, 9. So we have 9 times the x minus 2. That quantity of x minus 2 does not change. Excuse me. 12 divided by 3 is 4, right? So 4 times 2 is 8. And then we have this x minus 1/2. Okay. Is everyone okay with that? All right. Equals. What's 12 divided by 2? 6. So I'm going to take 6 times this x plus 1. Okay. All right. Does that make sense to you guys? Okay. All right. Now, do we know how to distribute? We should. What's 9 times x? 9x. 9 times -2? -18. -8 times x? -8x. What's a negative times a negative? Positive. And what's 8 times 1/2? 4, yeah. Equals 6 times x. And 6 times 1 is? Go ahead and combine like terms. What's 9x minus 8x? X. -18 and a +4, -14, equals 6x plus 6. All right, do you guys want to move the x or the 6x? 6x, and how do I move a 6x over? Subtract it. And what's 1 minus 6? -5x minus 14 equals 6. And then how do I move that 14? Add 14. So we have -5x equals 20. And then what? Divide by -5. So x is equal to -4. Got it. There you go. Yes, sir. Yeah, let me write down your assignments and then as soon as you can go. Okay. All right. Is there any questions on this? Okay. Couple things. Make sure you bring this back next class for me.